Hello everyone and welcome. Thanks for taking the time to see this talk. Just to introduce myself, my name is Paul. I currently work as a principal software engineer for a company called Anaplan, working on their mobile app. And this is one of my cats, Solomon. He might interrupt this talk, so I'll apologize in advance. So what is this all about? This is about what you do when the coding ends. You've created this amazing app. There are dollar signs in your eyes now. You need to ship it. I'm going to talk a little about getting your hands on Mac build hardware without breaking the bank, and a lot about the stuff you need to generate and upload along with an app, and how you can do that in an automated way to help you deliver your code and changes to your users visibly and quickly while keeping it looking great. And it'll mostly be automated, but more on that later. You might ask, what has this got to do with React Native? And it's a question I struggled with when I was writing this talk. I love writing in React Native. I've never had as much fun in my career as when I'm using this technology. And part of the reason I think I love it is how productive I am, getting stuff done on multiple platforms at once. But unless those changes are getting to the people using my apps, I'm not really delivering on that productivity. So I think this stuff goes hand in hand with React Native, and in some cases is enabled by it. So what do we actually need to do when we're getting our apps out to the app stores? Obviously, creating a release of the app is important, but within that, you need to ensure that you have set all the build and version numbers correctly, otherwise your build is going to get rejected. So automating that really helps, and not doing it manually from your development machine really stops you from getting some of that wrong. Then we have all this media that needs to be generated. Screenshots are a requirement for both the Play Store and the Apple App Store, even if they have slightly different specs. If you have users in different countries, then you might also need to be generating these once for each language. With multiple sizes needed for Apple, that can scale up in terms of work quickly. If you're a huge company with a dedicated branding team, maybe that's okay. But when I'm a sole dev trying to get my own app out there, it really isn't. And you have the same issue with any videos of the app you want to provide. And you do want to provide a video if you want to get featured on the App Store or get people to take your app seriously. So lots to do. I thought I finished coding the app. Why am I not rich yet? Doing all this stuff every time you want to ship a new app version not only takes loads of time, but that's a lot of places where you can get a process wrong or introduce human error. So what I want to advocate is really automating as much as we humanly can, and doing it as part of our CI/CD pipelines we hopefully already have in most modern software projects. And I mean this not just for companies, but I'm a huge believer in doing it for my smaller personal projects. This talk is based around an app I maintain for helping people play board games. The game is called Warhammer Underworlds, and the app is called Underworlds Helper. It has one developer. It is completely open source, but every upload to the App Store comes through a CI pipeline that runs when I push my deploy branch remotely. As a lone dev, I don't have bags of cash to spend on fancy build servers, and we know we're going to need some Mac hardware to build and deliver those iOS apps. There are some options though. Travis CI used to provide completely free Mac build hardware for open source projects. If your GitHub repo was public, you were golden. Sadly, that's changed recently. GitHub itself now provides a really good amount of free Mac build minutes with GitHub Actions, both for private and public repos. And Mac Stadium, one of the big Mac clouds out there, does offer free build time for open source projects, but you have to fill out a form and pray they like you enough. So when I started this app a few years ago, Travis was free, so I settled on them. But I'm actually keen to try moving over to GitHub Actions at some point and see how that goes. But enough about release builds. As I said earlier, that's probably a different talk. Let's instead turn towards some of the cool stuff you need to deliver alongside your app. Screenshots can make or break you on the App Store. So if we're going to generate them in an automated way, how can we do it without compromising on quality? If we look at the Play Store guidelines first, we see there are a couple of hoops we know we're going to need to jump through. We need a minimum of 2 images, no more than 2:1 aspect ratio, with some relaxed resolutions actually. However, Apple, we have to deliver separate screenshots for the full screen iPhones, for iPhones with physical home buttons, and for iPads. For iPads, you actually need to supply 2 sets of images, but they have the same dimensions, so you can reuse the same at least. I don't want to do this manually. I don't own all the devices. As a React Native dev, maybe I'm working on a Linux or Windows machine, so I might not even have access to simulators. There's another great reason to shift this into an automated process that runs on a build machine in a cloud somewhere. But how can I generate the screenshots I want with my app in all the different states I want? I went for Appium as my tool of choice. There are other similar options like Detox, and if you're lucky, you could even use React Native Web and try automating a web browser with Puppeteer or another framework. Appium actually uses the same protocol as Selenium, and this is a nice standard built around HTTP requests to send commands. So you might already be familiar with this kind of system if you do any web development. The idea here is to script real use of your app, actually opening it on a device, navigating to screens, interacting with it. And this ability to drive the app in a scripted way gives us repeatable actions that A, provide us, prove to us that our app is working the way we intended, and B, give us an opportunity to capture the app while we're driving it to these states. What does this look like for our React Native app? This is a typical setup. On the left, we have a test runner where we can put the logic that drives the app. This will talk to our app via an Appium server, which we'll need to launch beforehand. The Appium server, in turn, is going to talk to our device or simulator as appropriate. When running a test, we provide Appium with the desired set of what they call capabilities. And this is really a description of the device we want to run the test on, and it includes the location of our app. Appium takes care of installing our app on the device, and it also installs a second app on there, the WebDriver agent. And this is where the magic happens. The WebDriver and our app are signed similarly during the install process. And this lets the WebDriver agent, which is going to receive commands from the Appium server, interact with our app in ways that are normally restricted to the operating system and native testing frameworks like XCUI test or Espresso. Now we can start sending commands like find this element or input text or press that button, and we can do that from our test. We can even interact with biometrics on simulators and emulators, which is actually really cool. And given what we've just described so far, you can imagine that this could be scaled out so we can run these tests against all device form factors that we're interested in together. Though in reality, you are more likely to end up with something that looks like this if you want to go down that parallelizing route. I found there are issues with trying to run multiple devices from one Appium server, though in theory you should be able to do it these days. And you can use Selenium Grid if you're familiar with that, I believe. But let's stick with the basic case. We can always run our tests one by one and parallelize later. And let's finally look at some code for this. As this is for a React Native app, I prefer to keep as much of my code in JavaScript or TypeScript as possible. And in this case, I'm using Jest as my test runner. We need to ensure we have Appium and a WebDriver client installed. I chose WebDriver IO for my WebDriver client. There are other options, and we need to start our Appium server. You'll notice I'm installing it locally and starting it from within my node modules. This is because I'm expecting this to be run on a CI server at some point. And the more dependencies I can encapsulate in my project, the less I have to worry about the state of the server and what comes pre-installed on it. Plus, most CI systems offer some form of caching. So if I cache my node modules, I get the Appium install cached for free. And then I'm running my tests, though I'm setting an environment variable for each test with the name of the device I want to run on it. It's a nice way to parameterize Jest tests. The actual code isn't necessarily huge, though this is a noddy example. I would advocate using the page object model if you're really going to do all of this, where you model each screen in your app as a class and make the interactions on that screen functions that you call on that class. We know we're going to pick the device config based on the environment variable, and these are the Appium capabilities I mentioned earlier. This is what we're asking Appium to run our test on. In this case, an iPhone 11 Pro Max simulator. And Appium will actually launch the simulator for us too, which is very convenient. Before each test, we're going to get a fresh WebDriver IO client for our given device. Then in our tests, we can start issuing commands. In this case, the dollar function means select element, and the tilde at the start of the string means select by test ID. Here is what the React Native code that this is interacting with might look like. The command will give us back a reference to the element, not a React reference, but really just an ID that Appium can use to refer to that element. And we can do things like tap on that element with the click function. And once we are on a screen we care about, and the app is in a state we care about, we can take a screenshot and save it to disk. The images that this produces are the right size for the device it was run on, great quality, and always up to date with our app. Not only that, but you can pass in the locale in those Appium capabilities. So if you need to run your app in Japanese, French, German, it's easy to do, no messing around with device config settings. There are trade-offs. For example, the first time you run it, it will take a while as that WebDriver agent app has to be compiled. And on Android, you have to use a different prop. You have to use accessibility label instead of test ID. And the element you are setting these on needs to be an actual React Native one. You can't set test ID on one of your own components and expect Appium to find it. You'll need to pass that down to a text or view inside your component, for example. It's also not really appropriate for apps that don't have a stable state. Now, granted, most React Native apps tend to end up in a stable state. But if you've managed to write a fast-paced 3D game, this isn't going to work for you. Congratulations for doing that in React Native. I did say we were going to make these screenshots look awesome, though. Just showing what your app looks like isn't going to get you those millions of dollars in downloads. So how do we make these screenshots really sing? I'm going to keep running in JavaScript for as many things as possible, and that includes image manipulation. Sharp is a nifty little library that runs in Node, so we can actually use it during the jest tests we were running earlier if we want to. What do I want to do with my screenshots? Well, here's what they'll start off looking like for my app. The first thing I want to do is shrink the screenshot a little and put it on a black background, the same size as the original image. With the space we've now made at the top, we can add a little context about the scene, some nice marketing text in a fancy font. But we're dealing with an image manipulation library here, so we need to treat the text as an image, and this is where SVGs are really convenient. As before, we need to make sure we install the Sharp library, and as I'm introducing a utility function that takes an image and adds some text to it, and we're going to look at the code for that. First, we need to read in the image using Sharp, and then we want to resize it down, in this case, to 80% of its original size. We do that by grabbing the original width and height from the image metadata and multiplying it by, in this case, 0.8. We'll hold that in a buffer for now, but when we add it back into the original image later, we want it to be in the middle and at the bottom. We can do this with this gravity option later. Next, we'll create the background image. Now, for us, this is just really a big black box, and it's the same size as the original image. So again, we're using the width and height that we got from the original image metadata. Next, we'll add in the text. I'll dive into this a bit deeper, but it's worth noting at this point that we have this variable called vertical text space, which is really just the 20% of space we're going to be left with at the top of the image. We also pass in the original image width and height here because it's easier to think about the SVG layer as being the same size as the original image, or at least it is for me. Finally, we can compose the three images together and we can write the result out and even overwrite the original image if we're feeling brash, though if you want to do this with multiple languages, I'd recommend keeping the original as is and writing to a new file. I said I'd come back to the SVG generation as it's kind of interesting. So this is our utility function, and we passed in that vertical text space argument, which is the 20% of space at the top of the image. So let's ignore the rest of the image for now. Within that space at the top, we want the center for the text so that we can find the midpoint to put that text in. But the text isn't always going to be one line. In this case, it's actually going to be 3 lines. We get that by breaking the text on new line characters. So we want to work out where the first line is actually going to start by shifting up from that midpoint. And you'll notice that we're actually separating the concept of line height and the line itself. The line height is 10% bigger than the font size. So we're shifting that up by whatever amount we need to as appropriate. Finally, we can loop over the lines and add text elements to our SVG, offset by the right vertical distance based on our line height and the index of the line. The SVG, as I mentioned earlier, is actually the same size as our whole image. So if we get the placement of the text right here, we don't have to worry about positioning the SVG later. It just sits over the whole final image. Great. Now we can programmatically generate our screenshots and then add some final polish with some marketing text. And that's a pretty basic version of this. The sky really is the limit here. You can do so much more, like focusing on a particular element. In fact, you can screenshot individual elements during the test in Appium just by selecting an element and calling save screenshot on the element rather than on the client. Or you can crop the image as needed in Sharp afterwards if you always know where a particular element will be in a scene. Or you could do some rotation effects, composite several scenes together. Instead of a plain background color, you could have a nice blurred stock image. You could add device frames. They're something that's really popular in a lot of App Store listings. It's something you can have fun with. And if you're already using something like Fastlane, there's a utility in that called Frame.it that can help with some of this processing too. Great. We have all our screenshots all up to date, generated as part of our build pipeline. Now we just need to upload them in an automated way. And this is where I have to admit, I bailed on my own premise. I've not had the time to automate the uploading yet. But it is on my list of things to do, and it isn't too difficult. So I'm quickly going to run through what I intend on doing. I briefly mentioned it before. Fastlane is a fantastic utility and absolutely necessary if you're doing any kind of continuous deployment with mobile apps, React Native or otherwise. Really, it's a huge pile of Ruby that some guys at Google are constantly backwards engineering from Apple and Google's private APIs. It's bonkers. Within Fastlane, the deliver package gives us the ability to upload to Apple not only our apps, but also all the things that go with an app, including screenshots. And the equivalent of deliver in Fastlane for Android is called supply. It does much the same thing, but for Google's Play Store. Let's start with supply. Once you have Fastlane installed, you can run supply init, which is going to bring down this folder structure for you, picking up what you've already got on the Play Store in terms of app metadata. Then we move all the screenshots into the various directories, which are organized by language code. Once you're happy with all the images being in place, you can run supply to upload the screenshots. And since supply can do all your app metadata and the app itself, you can do this all at the same time if you want. On the iOS side, deliver works in a very similar way. You run an init command to download all the existing info, including the existing images you have. The directory structure is slightly different to Android one, but it has the same concept of this language code separation. Again, we just need to copy all the appropriate screenshots into place. Deliver doesn't need different resolution images in different directories or named in any particular way. It actually uses the resolution of the image to work out which device it's uploading for. And once you're happy, you run deliver to upload the images. And if you want, you can upload your metadata and upload your app at the same time too. Now, images that are localized, up to date, and looking professional will get you a long way. But a video can really raise your chances of getting people to download your app. Is it something that we can automate too, while keeping that high standard? For the Google Play Store, your video actually needs to be uploaded to YouTube, and you provide the store with a link. It can't have ads turned on, but that's about it. Otherwise, it's a pretty relaxed set of guidelines to follow. For Apple devices, like with the screenshots, we need multiple videos, and there are a few more restrictions on what we need to deliver. Videos can't be more than 30 seconds long, and they have to be provided in the right formats with the right encoding. And if I have to do different videos in different languages for 4 devices, that's a lot of manual video editing. If I want these to be up to date with my new app features, I'm going to spend more time in iMovie than I am coding features. I don't have a marketing department, so I want to automate as much of this as I can. And since we're already driving our app to record screenshots, why not record a video at the same time? Appium actually provides this functionality to us, though you have to make sure FFmpeg, a command line video creation and editing tool, is installed, as it's what Appium uses. So this is where we left our test code that was driving our app and taking screenshots. We can add a couple more lines here to start recording the video, and at the end of the test, stop the video being recorded and save it to a file. And when we start the recording, we can specify the format and quality we want. If you were recording videos of, actual, say, end-to-end tests, you could easily see what happens when they fail. And you probably don't need super high frame rates for that example. But in our case, this is supposed to be eye candy for our users. So we'll go as high as we reasonably can in terms of quality. One more thing to note, the Appium docs describe a stop recording screen function, but here we're using a save recording screen function provided by WebDriver IO in this case. The big difference here is stop recording screen returns a base64 encoded string of your video data, which you have to correctly encode and write to a file yourself. Save recording screen does that bit for you. So what are the results of these 2 extra lines? Well, the video it produces hasn't lived up to my expectations, if I'm honest, though I'm almost certain it's something that I'm doing wrong. The quality is even lower when I play it on Google Slides for some reason, but the actual video has these artifacts when large areas of the screen change. It's like, when I navigate between screens, a lot of pixels are changing. It's the kind of thing you would see in a badly encoded DVD rip from the early noughties. And the speed of the video doesn't match that of the original playthrough. All isn't lost though, as there are some other ways that we can start and stop the video capture on our devices during a test run. On iOS, the simulator control utility, which is similar to ADB on Android, can be used to record videos straight off of a simulator. This works really well and produces a high quality video. You can use child process in Node to kick this off and kill it at the end of the recording. Similarly, on Android, ADB actually provides a screen record command, though in this case, the video will be saved on the device. Even if it's an emulator, it gets stored on the emulator device. So you also need to extract it afterwards and probably remove it to keep the space clear. This video we can already see is a much higher quality, and the speed is the same as what actually happened during the test run. Though it's worth noting that if you leave it running with nothing happening on screen and then stop the recording, this technique will end up with all that waiting time being cut. This is because the codec used ignores when there are no changes in the video. Not a biggie, but worth being aware of for the end of your video, as it will end abruptly after the last movement on screen. While a high quality video of us tapping around the app is pretty cool, we did say we were going to make it look great. And more importantly, it can't be more than 30 seconds for Apple. At the moment, I've got about 2 minutes of video that needs cutting down to the good bits. And this is where I have to make another one of those guilty admissions. I currently manually edit my videos for this app. I do it in iMovie, and I have to do it multiple times, once for each device. I don't currently support other languages in this app, so I don't have to do it tens of times for each language, but I do want to support more languages in the future. I also add arty subtitles and, to describe what's going on in each point in the video, and nice music. And that makes this a manual process that is a huge no-no for a proper one-man shop. I only update this app twice a year. But if you're on your own, or even a small company with global ambitions, and you want to release often, this could be a real issue. Not only that, but doing stuff in iMovie always outputs at 1080 by 1920. So I also lose one of the huge advantages of screen recordings from devices, the correct aspect ratio. Well, correcting the videos I produce in iMovie is something that I can script at least. A quick look at the Apple specs tells me what I actually need. I need to crop the video to get it to rid of that widescreen space and scale it to what the App Store requires. And we already have FFmpeg installed, and it lets us crop the video quite easily. All we need are the width and height of the area to crop to, and also the top left corner to start that crop from. The FFmpeg command is pretty readable, and we're just passing in the video, some variables, and telling it where to write to. Now we're left with just our mobile screen. We next need to get the scale right. Again, the FFmpeg command is fairly readable. I'm just setting the new scale with what is required by the Apple spec for a given device. And that's it. 2 commands and our video is back to being in the right format and ready to be uploaded to the App Store. Here's what the commands look like when I'm running on the console. I check them into my repo so I don't lose them for next time, but you'll notice some funny numbers in those crop commands. How did I work out what areas of the screen I need to crop to? Well, I actually did it by eye, with some trial and error. It doesn't take long, and once I had the values right, they're fine to reuse again and again year after year. I'm sure someone cleverer than I am could have done the maths and worked it all out. But it doesn't really matter if I'm out by a pixel or two, as long as I get rid of all of the widescreen black space. The scale command is going to make everything, look pretty correct at the end. A quick note on background music. The sound effects, that I add to the video and the music that I add, I want it to be something that's professional and that someone is going to want to hear when they're watching the video. And this is actually pretty easy to do. I get my music from freesound.org, where you can find loads of free material to use. You just have to abide by the licenses on the file. Often this just means including a credit to the artist, which I add to the App Store listing and also to the YouTube video description if I upload it there. Here's a little snip of the audio I chose to use for the Underworld's Helper app video. So, manually cutting the video, multiple videos, manually editing sound, manually uploading. I don't want to keep doing this. So let me show you what I'm planning to do next in my automation journey with video. Our recording might be a few minutes long, but we just want the best 30 seconds of that. And it likely isn't continuous. So how do we programmatically cut the right bits? Well, the only point we actually know what is happening on screen at a given moment is during the original test run. So that is the best time for us to mark these so we can cut the video into individual clips later. If we go back again to our test code, it's actually fairly easy to record this information. We just need to add a couple more lines to, that record first the initial start time of the video. And at this point, I'm also introducing a structure for us to record timings of individual clips into. And when there's an interesting interaction about to happen that we want in our final video, we can mark the times. At the end of the interaction, we can push the start time and the end time into our clips array. And using these timestamps, we can cut the clip later. As we add more clips to the structure, it grows, and at the end of the test, we can save the JSON to another file alongside the video. Now, you could, if you wanted, just record each interaction as its own clip, so you don't have to cut them up later. But due to what I said before about the video recording cutting abruptly if there weren't any more interactions, I personally found it easier to manage this with one long video that I chop up as needed. I can add padding time around my clips more easily if I want to this way. Now I have my video file and my timings file, but how do I actually operate on the video file based on this? Well, we already saw a tool for scripted video editing. We used FFmpeg earlier for cropping and scaling the videos that we got out of iMovie. So instead, we can use it here for chopping up our video into the clips we care about. Actually, cutting the clips out is pretty easy. We can loop over the clips array in our JSON and make this FFmpeg command, finding the start time of each clip relative to the start time of the video and the duration of the clip by taking its start time from its end time. Now I've got lots of short videos rather than one long one. So let's stitch them back together. We want to do this in a lossless way, and the FFmpeg docs recommend converting our MPEG-4 to MPEG-2. This is because MPEG-4 is very clever, has all sorts of interesting things like seek points encoded into it, whereas MPEG-2, you can literally concatenate the bytes of two files together and get seamless video. So for a quick FFmpeg command to turn each clip into an intermediate MPEG-2 file is needed here. For those wondering, the .ts file extension here stands for Video Transport Stream, which is the MPEG-2 format. It doesn't stand for TypeScript file. Finally, we concatenate them back together with another simple FFmpeg command and re-encode the whole thing back as an MP4. There's probably a way to do this without the intermediate files. FFmpeg can work on many streams at a time. So again, if you're cleverer than me, you can probably work out something a little more elegant here. What about transitions? Just gluing our clips together might be jarring for someone watching the video. And in iMovie, I used a zoom blur transition to hide where I glued the clips together and, to let the person watching it know, hey, the next thing you're going to see is going to be different. So can we do something similar on the command line? And that's probably a little ambitious to try and achieve the same transition as a mature tool as iMovie. We could happily get away with a flash or fading in and out, but I put a bit of thought into how I would script that zoom blur transition using the zoom pan and directional blur filters in FFmpeg. Imagine we have our two clips that we want to join. I need the 500 milliseconds at the end of the first and the start of the second. On this little section of video, I need to apply my filters. On the first 500 milliseconds, I'm going to zoom in and apply the directional blur, over time increasing the zoom and intensity of the blur, and maybe changing the angle of the blur direction too. On the second 500 milliseconds, I need to do the reverse, zooming back out and reducing the blur. I've not tried doing this yet, but I think it could be fun to play around with, and it really gets me thinking about what I can and can't achieve with these command line tools. What about adding text into our videos to let the person watching know what's going on or how can they interact with the app? Well, earlier we marked when interesting things were happening during our tests, and I think that's also the right time to describe what's happening in the app, for that given clip. If we want to add that description in text to the video, then this is a good time to make sure that we've got that text down. So back to the test code one last time, I promise. When we were here last, we introduced this metadata for each clip. Now we can modify the code so that along with the timing of the clip, we add the text that we will add into the video. All we really doing here is pushing one extra string into the structure. In my case, I went with the text that will end up in the video, but you could equally just put an ID here if you want to keep the actual text, separate in a translations provider, for example. And so this is what I end up with in my video timings JSON file, with the clip text being alongside the start and end time of the clip. Great, we've got the text, we know which clip it should go with, but just throwing text up into a clip is boring. We can do better. In iMovie, I use this fun text effect with kind of this falling and fading going on. Again, it would be more than good enough to have our text fade in or move in from one side. But can we replicate this nice effect too? There is a draw text filter in FFmpeg that does let us put text in the video and control some aspects of it, like moving it over time. We know how long our clip is, and we can put our text in the central section of that without too much hassle. So it's not right up at the edges of our time. It'll just come in after, half a second and leave, a second before the end of the clip. But when we take a closer look at what's going on, with this iMovie effect, we can see the first character of each word acts differently to the rest of the word. So for each word, I need to break it in two, then perform two animations on each of those bits, not to mention position each one of them correctly in the video. I'm sure this is all doable. And I found some encouraging info on how to move text over time in some Stack Overflow comments. But the positioning scares me a little. on top of the transform for opacity in and out, and the translation of position, I think placement might be easier using something like SVG manipulation. I imagine cutting different SVGs for each character or each run of characters. And each SVG would be the same width and height as the original video, like we were doing with the screenshots. I think this will let us get each bit of text that needs to be animating into the right place initially. And then we can apply transforms to each of them individually over time and overlay the resulting videos on top of each other. Now, this is where my brain has gotten to with this one, but I'm keen to find the time to try and make it work at some point. A quick note on adding the audio. Again, it's very quick and an easily understandable ffmpeg command here. In this case, I've added an argument to shorten the audio so it's no longer than the video I'm adding it to, as I'm adding the audio at the end of the process. I'm not going to linger on this. You can find out how to do fade in and fade out on audio and ffmpeg quite easily online. Now let's talk about getting these beautiful masterpieces that we've created on the command line in an automated way, in theory, uploaded in an automated way. We used deliver and supply to get our app's screenshots up, and I had hoped that we could do the same thing for our videos. Alas, neither of them can help us here, sadly, which is actually a little bit frustrating. But there are ways around this to a certain extent. Spaceship is one of the underlying libraries that is part of Fastlane, and actually it's what Deliver uses under the hood. I found an example in a GitHub issue, which is referenced by a few people, of how to use Spaceship to upload the app preview video to Apple. I've not tried it myself, so I don't know if it actually works, but it looks pretty promising. A lot of likes. For the Play Store, we actually needed a YouTube video link. Now, uploading to YouTube programmatically is supported by their APIs, well documented online. But what I couldn't find a way to do programmatically was update the reference to that video in the Google Play Store console. I feel like there's something missing from supply here, and there's maybe the potential for a little open source PR from me at some point. So, how are we doing on this App Store checklist that we started with? Well, in theory, we've got those great screenshots that they're generated in all the formats we need whenever we push new code. And we've got our promo video being captured, cut, and beautified whenever we push new code. And because we have automated all of this, in theory, we can scale up the number of languages we're getting our app out in, not just functioning in, but also appearing to the markets in their own languages on the app stores. Our features will reach our users, and our app store listing can always be up to date and looking great. In theory. Now, I completely accept as an individual, this is probably overkill. The whole automation process has been a brilliant way to procrastinate from actually doing any real features on the Underworld's Helper app. But I'm okay with that. I get a kick out of automating this stuff. And it is, investigating things like this that I find helps me progress my actual career and my work. And it's something that I genuinely find quite interesting. So next time you find yourself manually doing something to get your app out there, just take some time and think about whether you can automate it in the future. And thank you for taking the time to listen to me.